Right, let's have an attempt. You need to take a good set of notes in this. This is quite critical. This is the first setup for how to learn how to program for the car park. So I'm going to show you the setup procedure for the different rungs that you're going to work through. I'll show you the first two, explain how you get the answer basically from that. So up first of all is what I want to show you, and make sure we before you go you get a copy of this, if you could please. Is what did I do it? Drive. I have some here. See if I've got enough. Right, so from your task sheet, the first point here, it says the entrance to the car park's on the left hand side. So remember the car park where you figure out the I/O from before. It says when the car arrives at the entrance of the car park, it operates the inductive sensor IP6. So if we flick back over to the Word document, so inputs you have IP6, which is on the ground. When the ticket button is pushed, IP0. So this here is the inductive underscore ENT, I'll call it. And this one is the ticket button, so I go TB underscore ENT as well. The barrier OP0, so output this time. We'll call it barrier underscore ENT. So everything with underscore ENT, just to signify that it's the entrance side of things rather than the exit side of things. Then finally it says here, should operate after a 2-second delay to allow the car in. So that's part of your inputs as well. It's not an actual physical one, but we'd still have this 2-second delay that we require as well. Now, when it comes to programming, there's a couple of ways you can do it, but really the best way to do this is to, number one, find out what you want to turn on, and then number two, how to turn it on. So from here, what can you identify as the thing that you need to turn either on or off? Yeah, the barrier. So if I have the, scroll down a little bit. So go to your programming software effectively at this point, and what I'm going to do is detail them with their absolute address up at top, and then down below their symbolic name. So that's an output operand of OP0. Okay. Now we need to try to figure out how to turn it on. So number one, what to turn on, and that was the barrier, as in to lift it up out of the way. And then number two is how. So from the text that we have here, and I'll get you handouts of them before you leave, it says the entrance of the car park's left hand side. That's fine. When the car arrives at the entrance of the car park, operates the inductive sensor IP6 on the ground. When the ticket button's pressed, IP0. It operates the barrier after a 2-second delay. So what I'm going to do is I'm going to show you sort of 5 images here, or 4 rather, of the different stages at which the car can be at. So what I want to do is, I need another page first of all. So stage 1, and forgive the hieroglyphics, but we're going to basically mimic this with the car in 4 different states. Yeah, you can put it in below, yeah. Just keep it separate from the main bit you're doing. Just your normally closed diffuse sensor, which shines the beam of light across. You then have the barrier itself, and that would lift up out of the way. We've got our inductive sensor, which is on the ground, which is the wee blue button, and then you've got your sort of roller switch that sits off to one side, if you remember the car park. And a dreadfully drawn car is about to appear. Just going to be a square box, that's all. Okay, so that's stage 1. When the car has arrived, it's on top of the sensor, but it's in position, not necessarily that the ticket button's been pressed. Stage 2 is now going to be that you have the sensor, which is wired normally closed again, beam of light, barrier, or rather, barrier is now up, and the car is in this position, just short of touching the beam. And then obviously you still get your dot down here, and then the roller switch. Stage 3 this time will be normally closed. There's the beam of light, and this time the car has moved in front of it enough that it's now touching the beam for the first time, so the beam reflects back. And then you obviously still have your barrier here that's now up. You get your dot on this side, and your inductive and the roller switch on the far side. And then finally stage 4. And again, normally closed, beam of light going across, your car still going in the distance or the direction of travel through into the car park, but this time the back end of the car has cleared the beam of light. And then obviously you've still got your wee dot and your inductive sensor and your roller switch. So if you look at what we have, we've got the car arrives up, stage 1. Stage 2, the barrier goes up and the car moves forward. So basically you're not on the sensor anymore and you're not pressing the ticket button, but the barrier's up. Stage 3, the car now breaks the beam of light, reflecting it back into the sensor, which actually turns the sensor on, but because it's wired normally closed, it makes it go from a high state to a low state. Okay, and I'm going to draw a wee chart for that in a wee second. Stage 4, again the car's moved further through this time, and I forgot to draw the barrier. The barrier's now sort of there. The car's completely through the beam of light as such, and the beam of light now continues straight through and the sensor goes back to being off. Okay, so I did not mean to do that. Try that. So in stage 1, the sensor is displaying a 1, as in it's on. Okay, because it's wired normally closed, so when there's nothing in front of it, it's in a closed state, and therefore provides a 1 in. If you think about it of push buttons, if you have a standard push button like this, and if you imagine the box on the far side, you write a 1 in it. If a voltage arrives in, you write a 0 in it if no voltage arrives in. In this state here, you would write a 0, okay? Because it's normally open and it hasn't been activated. Right? And then you could also have normally closed push button like this, and without it being operated, you'd write a 1 inside it. So this is basically the same as this. So instead of it being a push button, it's now an optical sensor, diffuse sensor. So this sensor's on because there's nothing in front of it. This particular one, is it on or off in this state? Yeah, it's still on. The car hasn't actually broken the beam yet. What about this one here? So the car is now in front of the sensor. Yeah, it goes to an off state. And then here again, the sensor goes back to a 1, right? Because there's nothing in front of it. The car's completely cleared the beam of light. Okay, so that's the first thought you need to consider in your head. So back to this part. We're trying to develop a program, so we need to figure out the logic for it. We're told that we need the inductive sensor to be active, we need the ticket button to be pressed, then a 2-second delay happens, and then the barrier should go up. Okay? So we've done all our standard logic exercises with your multiple AND, multiple OR, and so on. So we should be able to very quickly figure out obviously that should be a straight line. We have the timer, we've got our input, Q output, PT and ET. PT is preset time, ET is elapsed time. Or it's actually, I think it's PV, preset value, which we load there with the amount, so 2S for 2 seconds. These here input instructions, we label them with IP6, IP0. So that is the inductive on the entrance side and the ticket button on the entrance side as well. So now you should hopefully be able to agree with me that this here output will become active when the car is on top of the inductive sensor, the ticket button has been pressed, the 2-second delay elapses or happens, whatever way you want to put it, then finally that turns on, okay? Which is almost answering the first bullet point. So take each of these bullet points in turn. But the problem with that is this timer would deactivate as soon as its inputs get lost. So the timer's inputs are these two here, the IP6 and IP0. So that means you drive up in your car. So we'll go up to the image here. In stage 1, the car's on top, you reach out, you press the ticket button. Right? Forget about how the timer operates exactly. But if you press the ticket button, the barrier goes up. Then if you let go of the ticket button, the barrier will go down again because you've lost the input to the timer. Okay? So we've already talked about this 1 or 2 times before. I said it's one of the most important types of circuit that you're going to learn is how to keep an output on. Do you remember how you do that? What do you call a type of circuit that keeps an output on when you first turn it on? think it's example 8 and 9 on your simple ladder logic exercises. Any ideas? So, just for those listening at home, it's not that you can't hear anybody, it's just nobody said anything. Right? You don't remember this. Right? Start, stop, maintain. Yeah? Right, so these are your start conditions, the ones I already have up. You need some sort of stop condition, which will go in there eventually. But the maintain condition is the one that comes down, branches down, goes around your start conditions, and goes back in. Now, do you remember at least what you should label it with? Yeah, the same as the output, that's good. So, OP0, and it's bar underscore ENT. Okay, so think about it now. We're at stage 1. The car arrives up, so it activates IP6. You reach out, you touch the ticket button, activates this one. The timer starts, and after 2 seconds, the barrier activates, and your barrier goes up. This here activates because it's the same address, they're linked. Okay, so now you have a pathway down the way here, and also right along the top, which is fine, that's good. And then when you let go of the ticket button, you still have a pathway down the bottom, which keeps the barrier up the whole time. And you're allowed to move the car forward. So now, you're now at stage 2. You've moved forward, the barrier's up, and everything's so far going hunky-dory. So you've satisfied what is point 1 of the specification here. So point 2, it says, when the car moves through the raised entrance barrier, it activates a diffuse sensor, which is this one we're talking about here, the normally closed sensor, which is IP4, which allows the barrier, which the one we just were talking about, OP0, to close as soon as, and this is the critical bit, and this is the bit that's going to be the most confusing for you, as soon as the car is clear of the sensor. Okay, so there's a couple of things we've tried to learn to do with how to use normally open and normally closed things to activate outputs, okay? So we know up here we need some type of stop mechanism, because currently right now, if we downloaded this, the barrier would go up and would never go down. Agree with that? Right, no way I turn it off. So we actually need to put in a normally closed in here. And we're going to control it by a different network. Okay, and we're going to use a thing called the memory bit. We've used these before as well, M0.0. So therefore, that is now give us the next stage, M0.0. So we now need to, That's what, sorry?
Is that M0.0 the only thing we're going to put along that line?
Yeah, that's that now filled. Yeah. So when it comes to this section now I'm going to be drawing here, rubbing it out and redrawing here, so maybe just listen for a little bit for this point, and then you get the final part later on. So most people's first thoughts is to have the IP4, I think it was, the diffuse sensor. So diffuse underscore ENT to control M0.0. So that means when the car goes through the diffuse sensor, that activates, finish that off, which activates M0.0, and then that would open, which lets the barrier go down. Thought process seems right, okay? But we need to think it through. So at this point I do want to draw the wee graph for you that I was talking about. So if we use, oh sorry? Yeah, you can draw this bit out, yeah. So along the bottom, according to time, and here is a 1 state and a 0 state, so as in on and off for the sensor. So when you first turn on the system, the sensor, this IP4, which is the diffuse sensor, is on the whole time, okay, because it's wired normally closed, remember that? Okay, so when there's nothing in front of it, it's on effectively. And then if something goes in front of, so if the car moves forward and the front bumper touches it here, at this point, it goes to the off state here. So this here is stage 1, and I write it over here. This is car in front of sensor. And then it goes along the bottom for a little bit. So that's the car traveling in between here. Car moving along light. And then at this point, the car entire length has gone past the sensor, which is stage 4 of our other diagrams, and it goes back to being 1 again and then continues on with time. Okay, so there's stage 2 here. I'll write it over here. That is the car clears the light beam. Okay. So here is on, down there is off, and then we're going to add to that diagram a little bit later on. Okay. So if you think about it right now, this here would be active, because if you remember from previous weeks, we have a normally open contact, so N.O, and it effectively looks for a 1. The normally closed version of it looks for a 0. So if you have one of these types in your program, it looks for a 1 where it's connected. So for instance, if you have, I'm going to go back to our standard normally open push button, and then we'll use our box as our example again. So if you have that, the way it currently is, you would write a 0 in it. This here, if that there, and I'll call it PB1 for instance, if I call that PB1, so they're now related, this here looks for a 1. Does it find a 1? No, okay? Then you would put a 0 beside it, right? Now, if I associated PB1 here with this one, it looks for a 0. Does it find a 0? Right, so if it finds what it's looking for, it puts a 1 logic in, because it's found what it's looking for, okay? This is why it gets confusing. There's a lot of like double negatives and reverse logic here. So, thinking back to this part here, no, don't do that on me. This IP4, so that's the sensor. So you're at stage 1, the car is just on top of the inductive sensor and the ticket button's being pressed. So currently, is IP4 active or inactive? So it looks for a 1, does it find a 1? So remember, we're over here at, if I get the chart, we're over at this state because the car is not in front of the sensor. So it would be at a 1 here. Okay? Stage 1, nothing in front of the car. Therefore, the sensor would be given a 1. Sensor equals 1, remember? At that stage. So I'll flick back up here. So that means, and I wonder if I could change the color. a little bit. So that looks for a 1 and it finds a 1. Therefore that does not change colour. Oh, it's to do with ink tools, that's what's wrong. Okay, so that one becomes active. I'm just going to do a wee red squiggle on it to show it's active. Which means that one there becomes active straight away. Okay? Which means this one here opens. Frig's sake. Head on. I've had a glitch. So that opens. Alright, so let's think about this now. The car has arrived at stage 1. This here is looking for a 1 and it finds a 1. Why? Because the sensor is wired normally closed. It activates M0.0, which opens that contact. Which means when the car arrives, you press the button, the 2-second delay happens, you can't get through that, which means what? Well, not closes. Not quite. Well, it's not open yet. We're at stage 1. Car's outside. Yeah, nothing's happened yet. So the car arrives up, you press the button, 2 seconds delay, it stops there because that's open. That there can't operate, which means the barrier can't go up. So by using that as a normally open contact, we can never get the barrier to go up anymore. Okay? So what most people do, which is fair enough, is they go along and say this here should now be a normally closed. So they make that there now a normally closed version of it. Okay. So let's think through this one now. I want to change pen again. So remembering now that the normally closed version looks for a 0. Alright, and then it activates it. If it finds a 0, that is. And we're still at stage 1. Okay, so the sensor is on. So stage 1, sensor is equal to 1. So at this point here, this here looks for a 0. Does it find a 0? No, it doesn't. Okay, so effectively you write 0 here. Therefore that would stay off, this one here. Which means that there stays exactly as it is. So you now think about stage 1. You arrive at this point with the inductive. It's active. You press the tick up button. The 2-second delay happens. That stays normally closed, so you're allowed to go through it. The barrier activates. Yeah, which means this activates, and then you've now got a latch, just the way we talked about previously. So the car moves forward, and if you think about it now, car moves to stage 2. Everything's still okay currently. The beam hasn't been activated. You've let go of the inductive and the ticket button, and the barrier stayed up so far. That's still grand. The problem now occurs at stage 3. The car moves in front of the beam of light, and the sensor goes to 0. Okay? So let's think of how that affects it. So if you now look at, get this centered properly. If you now look at this one, so IPv4, it's looking for a 0. Does it find a 0 now? At stage 3 this is. Is the sensor on or off? Yeah, it finds a 0, okay? So it effectively has a 1 now, which means M0.0 turns on, which means this here opens, right? Which means this here now goes off, that there goes off, and the barrier goes down straight away. Okay, so when we had this here as normally open, we could never get the barrier to go up, right? And you've seen how that happened. Now we've changed it to normally closed, and the barrier goes up this time, and it seems fine. The car edges forward. The front bumper of the car breaks the beam of light, which is stage 3 in our drawn. And the problem with that is the barrier goes down straight away at that point, right? So unless you're driving at a good speed, the barrier is going to come down and hit your car. Right? It's not a good way to program things. Really, what we're looking for, and it's the critical point of this word here on the bullet point 2, it says, as the barrier will allow the IP4 will allow the barrier to close as soon as the car is clear. So how do we know the car is clear? Yeah, so when it goes back on, right? We've already tried looking for when it is on, right? What was the problem there when we looked for a 1? Well, it did find it. That was the problem. But what did that cause? So remember the first way I done it? What was wrong with the barrier? Yeah, it would never go up, right? So you're saying we basically need to find this point. Oh, wrong bit here, sorry. You've said we're trying to find that point there when it goes back to on. That's what you said there. Yep, which is what the text asks you to do as well. So we've already tried here looking for a 1, and the problem was that we couldn't ever get the barrier to go up. So we thought, right, it must be the other way. And you tried looking for a 0, which is that bit down there. And what was the problem there? Was the barrier would go down as soon as the car broke the beam, all right, which is useless as well. At least the car had the option to try and go through really quickly, but it's pointless as regards programming for a car park. So what we're looking for is actually this here, precise moment in time at when the sensor goes from off to on. And there's a special feature that you haven't seen yet you can do in this software. And if I find a bit of space, I'll show you. I'll do it down below here. So what you're looking to implement here, change the color back to black. What you're looking to implement is one that looks like this here. So it looks like a standard open contact, but it has a P inside it. It stands for positive edge trigger. The top side of it you label with whatever sensor you want to detect the positive edge of. So the positive edge of something is when it goes from 0 to 1. And it's only active, this here will only be active for 1 scan cycle of the PLC, which would be roughly somewhere in the region of 1 to about 5 milliseconds. That's it. Okay. The bit below it also needs labeled with something, and you use the next available memory bit number. Right, we're already using M0.0 as you can see up there, so we need to use the next available one, M0.1. So let's think about how this works now. So if I move this down a little bit and get rid of some of my pen marks, so get rid of that. Okay, so we're sort of back to where we're at. Get rid of that and put a P in there now. So we're now looking for the positive edge of this diffuse sensor that we keep talking about. Once given us all this grief. So currently, let's move that a little bit to center. I did not mean that. Right now, at stage 1, think about the car park back at stage 1. So the car rolls up. Is IP4 currently, has it just turned on? The sensor, IP4. Or is it on anyway? It's just on anyway, okay? So that is not active, which means this I or M0.0 is also off, which means that stays currently as I've drawn it, that normally closed M0.0. So, stage 1, car arrives up, activates this one here. I'm supposed to draw something here, for it's hard to know what I'm pointing at, obviously, if you're not watching. So that activates, and then the timer activates. 2 seconds later, the barrier goes up, and then that keeps it up. So it moves forward to stage 2. You're now letting go of that and that, but the barrier stays up because of this latch or the maintain. Okay? Now the car moves to stage 2, that's fine. Stage 3, the front nose of the car touches the sensor, or the beam of light, not the actual sensor. And then the sensor goes to the off state, right? So in our chart, that's when it plummeted down, right? Does this here do anything? The positive edge, right? Does it? No. It only detects when it goes from off to on. The sensor happened to go on to off. That's called the negative edge or trailing edge. Okay, so you get rising edge, trailing edge, or positive and negative as the two terms. So that there still hasn't done anything, which means M0.0 still hasn't done anything, which means this normally closed M0.0 still doesn't do anything, which means the car or the barrier stays up. So the car now travels through, it enters stage 4, that the car now clears the barrier completely, or the sensor, I mean the beam of light from the sensor completely. The sensor suddenly turns on, so it goes from off to on, which means now that this here becomes active, provides a 1 out, which turns that on. This opens, and then therefore that would turn off, that turns off, and your barrier goes down, and your car's now clear of it. Okay. Now, it is imperative that you understand what happens here. Like you would never believe. So, if there's any doubt in your mind as to what happened there, that's why I tried to show you right from the start, different stages, how we built it up. Because if I just showed you there and tried to explain it, you wouldn't understand why I done it that way. Each time I done a little bit, I showed you what the faults were with it. Okay, that's your thought pattern of programming pretty much. That is your final version of your first 2 networks. So the top one that you can see here is, we get a change of pen color. That's network 1, and this one down here will be network 2. Now, 1 and 2 relate to the input side or the entrance side of the car park, and then 3 and 4 relate to the exit side. Now, 1 and 2 are basically exactly the same as 3 and 4. Instead of having inductive entrance, you're now going to have inductive exit. Okay, that's the only real difference between them. The timer, see when you get onto the software to do this, the timer right now is not that important. I haven't taught you about timers. There's 4 different types of timers we're going to come across. We do not need to worry about them too much right now. Understand that it needs to work a certain way, but right now we're just assuming that it's working the right way we need. There's just too much information to bombard you with how to count and how to time at the same time. So just get the structure correct in your head, and we have still 15 minutes here roughly, so we're going to get you to log on and start to build this as well. Is there any questions about how that operates that is confusing you? It's a positive edge trigger. So it's a special feature. So see the way this here is normally open? It looks for a 1. They're normally closed, it looks for a 0. Okay? This looks for when it goes from 0 to 1. Okay, so only looks and only activates for a couple of milliseconds when something goes from off to on. So a normally open contact like this OP0 here, it gives an output from itself the whole time it finds a 1. This one provides an output the whole time when it finds a 0. This one, and if you use the other version, the N, negative edge, it would only be active for a very, very short time, milliseconds. Okay? So once something goes from off to on, that activates very quickly. which would operate our M0.0 in this case. Okay. So the problem was, when we tried to look for a 1, the barrier would never go up. So we tried looking for a 0, and the barrier would go down too early. But really, we were looking for when the sensor went on again, but only when it went to being on, not when it was on all the time. So that's why we needed the positive edge. If our sensor was wired normally open, then we'd use a negative edge. But that's besides the point right now.
But if that's only on for a few milliseconds or whatever,
Uh-huh.
is that enough to let the barrier come the whole way down?
Well, yes. So what you're thinking about there is when the barrier's in its up state, okay? And then the car moves forward and activates this positive edge. So the car clears the beam of light. The positive edge activates. M0.0 activates here at the bottom right of the screen. And then this one, what I've written open below currently, it opens. And what happens there is OPO, or OP0 rather, the barrier, this output here, wrong pen, this one here would go to the off state, which turns this one here, the latch, off as well. Right? So you're thinking short time. But if this one here, the latch, goes off, it means you can't get a path going that way anymore to turn it on, and you can't get a pathway going that way to turn it on. So it doesn't matter how long M0.0 is activated for. As long as it goes off, you lose your latch and it just stays off. Is that okay? Any other questions? It's probably good that I have a time to, one on the audio and on the board, so don't be coming back to me in 5-10 minutes time and saying, I got another question. Anything. Because there's another lot of stuff to take in there. It's the toughest lesson you're going to have off me, of making sure you understand this. Think of it as water and pipes if you want.
Once the car goes through, that then opens, which means nothing more is going through. It turns off the OP0, just off the other OP0, which makes the whole thing dead.
Only when the car's completely through the beam of light. Yep. 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 Is that okay? So one or two new things there. But really what you're trying to learn here is when you're programming, one, find out what you want to turn on, and that becomes your output, the thing on the right hand side of your program. And then you just need to figure out how you want to turn it on. And just do it in stages as you've seen. As I read off from the text, I started putting in symbols. Okay, so I knew that I needed the inductive sensor and the ticket button. So I know AND logic is series. So I put two normally open contacts in series. So you start to develop. We've already done the basic ones. Now we're trying to relate that a little bit further from the basic ones to this bit more complex. So happy enough? I stop recording. You want to say hello to Sam? Huh? Yeah, probably.